Hi, class. This is Dr. Condor, and I want to continue with working in uh, the beginning of the statistics course. And we've looked at types of variables and um, give an idea, an overview of what statistics is and population, things like population and sample, and then I want to just go away from this for just 1 second, and then we'll get into that book. But statistics in general, I'm going to write up here statistics. Okay, so is kind of broken up into two parts. And usually you're working with one of the, not that they can't overlap, but you have a focus in one area or the other at some time in working with a study or data collection and so on. And usually it starts over here on the left under what we refer to as descriptive statistics. Okay. So descriptive statistics talks about describing what's in your sample. Okay. So things that describe the sample. And then later, once you do that, then you talk about what we refer to as inferential statistics. Okay, so inferential statistics is over here. And normally, remember that statistics is collecting data and then trying to organize that data and interpret that data. Now, in statistics, we said that you have a population, a well-defined population, and then you're going to collect some data from that population. But we said most of the time you're not going to be able to get data or information from every element in that population. So you end up most of the time collecting a sample or part of the population, collecting information from part of the population, and we call that a sample. And so you have a sample, and what you want to do is you want to talk about the population based on that sample. Well, the first step is you have to see what you have in that sample. You have to be able to describe what you got when you sampled from the population. Okay. Now, once you do that, once you take and you organize the data and you interpret what you got, and then you can take that information and draw some inferences, or refer to as inferential statistics. We have statistical techniques that helps building confidence from going from a sample. And remember, the sample is only part of the picture. So we're trying to look at part of the picture and then get the full picture over here based off this part of this picture. So it's kind of like a puzzle. You're putting a puzzle together, but you kind of have a lot of pieces missing. But you still, if you do a good job describing what's in your sample, and then you should be able to tell, pretty much what you have and what that full picture would look like, and the full puzzle picture would look like. So for the first unit, we're just over here at the descriptive side. Then later we get into this. So under descriptive statistics, typically to start organizing the data, you want to create tables. Okay, so you do tables, charts, graphs, right? So these are things like visually try to get us organizing and interpret things. So we have descriptive statistics and tables, graphs, and charts. You have measures of central tendency. And my writing is not clear. It's hard to write on this writing tablet. Measures of central tendency. Okay, so then we got some numbers there. We like to look at the middle of the distribution and talk about the middle. In statistics, that's kind of how we measure things. We like to start in the middle and measure out away from the middle. And measures variability. So again, we like to take a look at numbers that help us tell how spread out the numbers are or far away from the middle. Once we decide what middle value we're going to use, and then we have measures of position. So position of values within a set of data values. So that gives us a lot of stuff that we could get going on in describing a sample. Okay, so what we want to do here for just a little bit is talk about this in here. There's tables, graphs, and charts. So I'm going to as soon as I can figure out where my, there it is. Okay. Okay, so let's go ahead and talk about what we have in the ebook. And again, the ebook, this may not look exactly like your ebook. I have several different sections and from previous semesters, some things. And so it all depends on which one I like the best. And so this particular one uh, was really the same authors or part of the author group from all the statistics books that we've used for a while. And so they're all good, but some, for certain concepts, I like a little better than others. And this one's very clear about how you get started. And they start with a frequency table. Okay. So you see, again, frequency table here. And that's probably where just about everybody starts organizing data, whether it's at the nominal level, ordinal, interval, ratio level. You can create frequency tables. So they're versatile and they work with all levels. And you see over here on the left, grades. Now remember, grades are ordinal level data. And we have groupings. We have an A group, B group, C group, D, and F. And there's also an order to the grouping. So ordinal, again, remember groups in order. So you create groups and then you list how many of the elements fell in each of the groups. Frequency or count. So our frequency table has groupings and counts. So this means 4 people got A's in this particular data collection here. 7 got B's, 9 got C's, 3 D's, and then there's a total of 25. So that's kind of a basic frequency table. Okay, it says it has 2 columns, the first list of categories and the second. So this is very common, good way to get started. Here's another one here. They say taste scale, 1, 2, 3, 4, 5. 2 people registered a 1, 3, a 2, and so on. And so now, frequency table lists counts. This is listing how many by count, like 3. I count 1, 2, 3. We're in this taste level 9, registered or recorded this, and so on. But you can also do things in percentages, and that's what they're showing here. First of all, they're saying we can create relative frequency tables. So if we get down here, look at this table. We look at those grades, A, B, C, D, and F. Well, we had the frequencies already. They're up here. Okay, so these first two columns are exactly the same. But we're adding another column here. It's called a relative frequency. And what that means is this count with respect to the total number that were in there. The total number of all of these we had here, we had 25 of these letter grades. Okay. And that was shown down here. Now, so if you take 4 divided by 25, you get 16%. And again, these, could be rounded, whatever. 7 people got B's. Well, how many is that out of the entire group? Well, that's 7 out of 25, or 28% of the people got B's. So they tell you two different things. A count or frequency tells you how many exactly were in that group. Relative frequency tells you the percent of people or things or elements that were in that group. So there were 9 C's, but that's 36% of the entire class. So like a third of the class got a C. When we just said 9, we didn't know that until we took 9 divided by 25. We got 36%, and 12% got D's, 8% got F's. All right. Now, cumulative frequency is kind of like what it sounds. It's accumulate. You are adding things up. But how many people got A's from here? If you do it this way, well, there were 4. So they put the 4 over here. So there's nothing to accumulate there. But over here, how many people got a B or an A? Okay. Or you could say a B or above. Well, this is 7 here and 4. So there were a total of 11 people got a B or better. That's what they're showing over here. Now, how many people got a C or better? Well, 9 C's, 7 B's, 4 A's, 9 plus 7 plus 4 is 20. 20 people got a C or better. So this is called a cumulative frequency, is when you add up and say add or above, or add some value or below, add some category above, add some category below. So let's look at this again. D's, how many people got a D or better? 3 plus 9 plus 7 plus 4. Add it up over here. Get 23. So now everybody together, all these together is 25, and that's what's here in the end. So you add them all up, you get 25. All right. So that's really about it for tables. We don't build them in this course. That's something if you take another course where you want to do a lot of graphing and charting and so on, then you learn them a little more. But for now, we just want to know, as we learn to understand statistics, is that, how do we proceed? How would we start? We start with a population. We got to go out and collect the sample. Now we know that we have to organize data, and we're going to start with a table. We're going to have a frequency table, relative frequency, cumulative frequency. So we're learning how we proceed through the statistical process. And here's relative frequency, the definition, the cumulative frequency again. They give you another example. I'm going to skip that, same idea. Now, bin, I just wanted to make a quick comment here. Bins are groups, that's all. So they're just saying if you have groupings. And if you have continuous data, or you want to set it up like discrete data, but there's a lot of numbers here, you can still create, they're calling bins or categories. So you notice here, 95 to 99, that's their first category. One person got a 95 to a 99. Okay, how many people went from a 90 to a 94? Well, there were 2. Total A's, 3. And again, you can do relative frequency, total of 20 grades. You take the number divided by 20 to get the percent. So let's pick this one, 80 to 84. 3 people scored 80 to 84. That's 3 out of 20. That's 15%. So same as before. You just have numbers here instead of letter. We had letters before. Now we got numbers. Cumulative frequency, exactly the same. If I want to know how many people got 80 or better, I take this group 3, add 3 more, 6, 7, 8, 9, right? So I add them all up and I get 9. 9 or 15% got 80 or above. So tables are good. They help us get going and get that data organized. We can start to see some things, and that's what's important. We want to be able to explore the data and interpret what we have. Okay. And then now we're going to jump to, this is page 99. Again, this may or may not be your particular E, but it's got the same information, same authors. Mario Triola's and the different books, a lot of the different books we use. He's a good author, so we like using his material. Okay, so now let's look a little bit more because we talked about tables and graphs and charts, right? Tables, talked about that. How about graphs? Well, there's hundreds of graphs out there. Literally hundreds and hundreds. You can go on the internet and look up graphing repositories where people create all these unique and interesting graphs. And you can use them. They're there for people to use. Some of them are pretty neat. A lot of them are very basic, and most of them they relate to one of three basic kind of charts. And a lot of them have to deal with this idea of what we call a histogram or a bar chart. And that's what we have here. So you've probably seen these. The things to remember is that the histogram is the most popular by far. It's the most popular graph. So if you're struggling with a set of data values, you think, what can I use for a display? And maybe, well, histogram. Histogram works with any level of measurement, nominal, ordinal, interval, ratio level data. And it's easy to understand. And that's why people like it too. Easy to interpret, and it's very popular. People like it. They just like these. So the bar chart again is has been tested. It's been around for a long time. Empirically, they show that people make less mistakes when interpreting a bar chart than any other graph that we have. So here's one. Here's the grades. So in reality, if you notice from this right here, we have those letter grades A, B, C, D, F, and then we know how many fell in each group. So we have our groupings, and we have the count of how many fell in each group. 4 A's, 7 B's, 9 C's, there were 3 D's, 2 F's, right? Well, that was the exact same information that was in the frequency table. A bar graph is really just a frequency table. It can also be a relative frequency table. If you look over here, here's the percentages of how many were in each of these. This last bar, it's up at 8%. 8% of the grades were F's, and so on. So again, a histogram bar chart here, it's just a frequency table. Just a little more visual, less threatening. People like them. They like them. So a good thing to use and have, right? So let's go past. And again, you don't have to construct. They used to, years ago, everybody didn't have a computer. There wasn't a lot of software out there. Things in the 70s were kind of just getting going, 80s. It's very slow. And as computers got better, then people started to use statistics more. Storage was difficult. A lot of computations, a lot of storage. So people had to draw this stuff by hand, but not anymore. a lot of free software out there. You can get data. All of you, if you're watching this video, you or in any of my courses, you have access to something called StatDisk. It's free. It's a nice little stat package. You can look at my materials I have and find it on Canvas and so on. And it'll build histograms and bar charts, things like that. Okay. So we're going to skip this because we do not want to do these by hand, right? We'll let the computer or even your calculators will create bar charts. And again, here's a couple more. You'll see cities. So you have 1, 2, 3, 4, 5 groupings. Population in millions. So they're saying how many fall in each of these groupings or these cities that they picked out, right? And a Pareto chart, he says, it just puts them in order. So this is a little more organized. You can swap them around because they're just one's not better than the other. They're just different cities. Some cities have more than the others, and so on. Okay, so we're going to continue on. Histograms again are good. And pie charts are another one that people like. And you'll notice these groupings, again, they just have groupings, right? And you can put the counts in here or the percentages like they have. So you can have a frequency pie chart, a relative frequency pie chart. Now, cumulative, it wouldn't work. That we can't do with pie charts, but they are visual. They don't really give you any more information than what you would get out of a histogram or a frequency table. Okay, but they're kind of nice. You can color them up and make them friendly for people. Again, they're interpreted usually fairly well. So here's got these 3 groups, very easy to see the percents of each one. And then one other one I want to talk about with the basic types of graphs. When we have you'll see he has a histogram here. And then he has what they call either a frequency polygon or a line graph. Now, why would you use one as opposed to the other? Okay, well, if I was going to put more than one set of data values on the same chart, this would get confusing very easily. So I don't want to do that. I would want to maybe look, if I had the right kind of data, I would want to use a line graph. So a line graph is better than a histogram when you have multiple sets of data values. You can put lines 2, 3, 4 on here and come up with a pretty readable data or a pretty readable graph. And let me see if I can. I'm trying to go over to my other monitor, and for some reason, I'm not getting it. There it is. Okay. Just going to bring this in, and you can see it's got 2 lines, pretty easily readable. This has 1, 2, 3, 4 lines on it, and it's still pretty reasonable. If you tried it with a bar chart, it wouldn't work. You wouldn't be able to read it. So there's definite advantages to line graphs. And the biggest one is, well, there's really 2. But if you're emphasizing increases and decreases, a lot of these graphs are going up and down. So maybe trend analysis, forecasting, things like that. Line graphs shows better if you want to display, want to get across. And that's kind of the key. You always have to think, what am I trying to get across to whoever I'm sending this report to? And then you think about the different graphs and you decide on which one helps you communicate most effectively what you're trying to get across. So definitely line graphs are good, right, for multiple comparisons. Histograms are not. Also, line graphs work with continuous data better. See, when you have bars, you think, are those groupings? Or is this all continuous through here? If you have a line graph, it's assumed that data is continuous. Okay. So that's another big difference on when you might want to use one as opposed to the other. And there's some other stuff in your book that we're really not going to talk about. And we're going to jump way up to, let's see if we can get up to, I think it's 157. Let's see what we got. Okay, box plot. Now, I like to talk about the box plot with the graphs because it is really become popular, very popular in statistics. And let me find my page. So I'm going to pause here. And then people like it. I like it. It's eventually in terms of like research articles and things like, people don't typically use histograms and that. They usually will use box plots. And so I'm going to find the summary, but I guess I don't have to. The book. All right, I'm just gonna go with this because I can't see the original one. But so quartiles, percentiles, measures of position. If you remember when I was showing this over here, we talked about descriptive statistics, tables, graphs, and charts. And then this is on another video. But I don't want to do a separate video for this. That's why I'm just going to talk about it right now because there's only a couple little things here. Measures of position. And the most common measure of position is in statistics is the percentile. Okay. Let me see. Okay, there we go. So a percentile. Okay, that's L-E-T-I-L-E, percentile. And a percentile is the percent of score, so percentile percent. All right. Percent of scores at or below a given score. Okay. So let's say I have a set of data values and you scored a 35, right? So score 35. And you think, it's pretty good. And then you think, well, wait a minute, how did everybody else do? Because a lot of times, you're compared. Measures of position means they're trying to figure out, what position are you in with the group of others. So if somebody's hiring, let's say, and they got 100 applicants and you score 35 and you think, oh man, I wonder how good that is. And well, you have to know, first of all, what the total score was, right? And so is that 35 out of 40? Is that 35 out of 100? And then you think, okay, well, that gives me a little better idea. Maybe I got 35 out of 40. I feel pretty good about that. But that still doesn't tell you if you're going to be considered or not, say maybe for a job or a position in some area, working with people and so on. So, because what happens is that 35 out of 40, that may be one of the lowest scores of all the people that took it, because you could have had a lot of scores like, 36, 37, right? 38 is another score. Above that, 39 and 40. So let's say that most people got all these scores except for a few people that got 35s. So when you thought, oh, 35 out of 40, I did great. But then when you found your measure of position, then you said, that's not really that good. Not as good as I thought, right? Because all these other people were above me. So by just knowing the score uh, is really not enough in some situations. Now, if you were at the 35th percentile, okay, regardless of your score. So again, this you look at your data one way. This is like a frequency table. Percentile is like a relative frequency table where it shows at or above or at or below. Percentile shows the amount of scores right at or below. So if you're at the 35th percentile, that means you are or did better or above 35% of the people in that group. So then you can say, oh, I'm not very good. You know right away how you fit in with respect to everybody else. So now, if you're at the 90th percentile, right? 90th percentile. That's good, right? You're up near the top. Now you're better. You did better than 90% of all the people that, right, were in that group. So regardless of what your score was, 35, 40, 20, doesn't matter, because in this particular instance, we're concerned about how we fit in with everybody else. Would be considered more so maybe for a position if we had a high percentile. So that's kind of the idea of measures of position. It's with respect to the other data values. And so I'm going to clear this off. And there we go. So let's say that you want to define percent. And we could do that. And what I'm going to pull in here, I've got to put a few of these things. And again, it's kind of going slow. But let's say we had some scores. I'm going to make it easy, the numbers here. But let's say that we had some scores, and like 3, 8, 9, 15, 2, 12. 1, 2, 3, 4, 5, 6, 8, 4, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll say 25, right? So what I'm going to do is to find percentile. Each number has its own percentile. We're talking just about this set of data right here. Okay, there's 10. What I got to do is put them in order. So from high to low, I'm going to put 25 is the highest, and then 20, and then 15, and then 12, and then 9, 8, 8, 4, 3, and 2. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you put them in order, because what we're trying to find is at or below. So order makes sense. Like if I look at 15, I can see all these numbers that are below 15. Right away, I can tell my measure of position is up high. Now, exactly how would we figure that? We just count. 1, 2, 3, 4, 5, 6, 7. 7 of the numbers out of the 10 numbers, right? And did I say 15 or 12? I forget already. 15. Okay, let me just draw a line so I remember what I said. There we go. All right, we're trying to find a percentile for this number. So at or below, whoops, got to add that 8. Okay, 8. Okay, so I am at the 8 divided by 10 is 80%. So I'm at the 80th percentile. So this score of 15, all right, is at the 80th percentile. Because 80% of the scores, right, 80% of the scores are at or below that number right there. So it's a pretty straightforward. And again, you can look in your book. He's got a couple examples on how to find that. All right, so percentiles. Now we're going to head back. We're trying to get to box plots. All right. So how does box plot ties in with percentile? And again, box plot is a graph, and it looks like this. Kind of see, kind of interesting looking. These are two box plots, so you can compare. Box plots are great for multiple comparisons. You can compare two sets of data values. They're showing at Best Bank here. The spread of data is like real small, goes from 6.6 up to 7.81. Median 7.2. You got these quartiles here. Big Bank goes from 4.1 up to 11, so it's all spread out a lot more than this one. So how do we make that? How do we create the box plot? And let me flip this over. Okay, good. Now interpreting box plots. All right. So we're going to use this one here. Number of hours spent studying for statistics final exam. And I'm going to put the numbers up here, and I don't know. Let's see. So this right here, this on the left is the, and again, I think it's not going to show, so I'm going to take this away. In fact, no, let me just talk about this first, and then I'll draw it back behind it. Oh. All right, so interpreting. So this line right here is at the minimum. That means right here, which looks like to be about 1. 1 would be my minimum value. This line right here of the box plot is at Q1. We call it Q1 or first quartile. 25% of the data, so think about 4 quarters at $1. So the first quarter, the first 25% of the data values all fall from here to here. So from like 1 to looks like 4 hours of studying. 1/4 of the people. The next, first, this is Q1. This is Q2, or the median. The median, that's the value where half of the data values fall above, half the data values fall below. So 50%, we got 2 quarters here. This is a quarter here. This is a quarter here. That's 50%. So that's got to be the median right there. Here's the third quartile. 75% of the data value falls at or below 20. And then this is the maximum. Looks like 32 hours was the maximum number of hours spent studying. Okay. So again, box plots are nice. Here's a percentile definition here. We were looking for that before, but so the box plots are really easy to count, and that's the whole idea of a guy named John Tukey in the late 70s. He created these. And he said histograms are okay, but box plots are even, he liked them because they were very easy to draw. You can create a box plot, no matter how many data values you have, you can create one pretty quickly and draw it out, like this. So that's why people liked it, but they still like it because it's clean, easy to interpret, and good for multiple comparisons and initial look at interpreting the spread of the data. So again, we can see from one way up to like 32. So there is a large spread or variability in this data set. We can see that very quickly with a box plot. And this interquartile range here, we can see 50% of the people were between about 4 and 20 hours. Big chunk of them were in here, and a big chunk of them were right here, 25% from, a lot of people, just about 1 to 4, right? A lot of them there. Not, right? These are all spread out here on differences. So, but we're going to conclude with that. And then on the calculator video, there's the, how to use your calculator and come up with those values for the box plot. So